Hey everyone, welcome to the next section. We'll be starting up density. Just as a reminder for this section, you should have a calculator handy, as there will be some mathematical calculations to figure out. So to start off with, the warm-up for today is what's the difference between physical and a chemical change. So I'll get you to pause the video, see if you can refer back to your notes and come up with an answer that might help out and satisfy this question. Alright, so between a physical change and a chemical change. Well, a physical change, the composition remains the same. And in a chemical change, composition turns into something new. So, in a physical change, if, say, folding a piece of paper, for instance, I can unfold that piece of paper and I haven't changed anything in the product. The material, the composition that makes that object stays exactly the same. In a chemical change, however, the composition turns into something new. So if I were to take a piece of paper and burn it, I can no longer get the original piece of paper back again. So there are different characteristics that we took a look at between physical and chemical changes, and if you're unfamiliar with those, I recommend that you go back and take a look at the previous video as kind of a reminder for those. So in today's class, we're really going to be moving and focusing in on density. We talked before a little bit about matter. Matter has mass and volume, where the mass is the amount of matter an object can have. So how crammed an object can be, as you can kind of see by that picture up there. Its measure is usually given in something like grams or kilograms. It's a fairly steady unit. Volume is the amount of space an object can occupy. So there's numerous units for volume, including things like liters, cubic meters, gallons, milliliters. You'll see a whole whack of different units that kind of play in with volume, and they're all connected. So this idea of mass and volume. Mass and volume are physical properties of matter, and they may vary with different objects. So some objects may appear light, some objects may appear really heavy. In the example that you can see here, I've got two objects that actually have the same volume. They're equal in volume, but yet one has a much higher density than the other. So if they were to be placed on a balance scale, the one with the higher density would obviously weigh more and push this down. It has more mass crammed into the same volume. So the little blurb below, if both pieces of metal are made of the same material, the ratio of the mass and the volume should be the same. So if I have one piece of, say, steel or aluminum that weighs 5 grams, and then I have a piece of steel or aluminum that weighs 10 grams, the volume would also go up in the same proportion or in the same ratio, because I would be talking about the same material that would be present. So a couple of different thoughts that are there that kind of all connect in together. So again, I'd encourage you from the last slide moving forward, if there's anything that you want to take and write down just to have for notes, I would recommend doing that, or whichever way you learn best to go through and retain this information. So let's start to get on to a little bit of the math involved here. This is our first equation that we're going to see. We define density, and then I've got a P here, but it's really not P, it's a Greek letter. It stands for rho, but that's the common symbol that's used for density. So it's actually not a P, it's a Greek symbol, but I can't find the same key that we're looking for on my keyboard, so it's very similar to this letter P. So we define density as a ratio of mass to volume. And we can see by this equation here, I've got density is equal to mass over volume. So here, the symbol M stands for the mass, V stands for the volume. Density is our symbol rho, which looks like the letter P, has the units of mass divided by volume, such as something like grams per cubic centimeter or kilograms per liter. So density basically is any ratio of mass compared to some sort of volume that's present. And that equation, density is equal to mass over volume, we can use that in a couple of different ways. So let's start off and we'll take a look at a couple of examples. So a block of wood has a mass of 8 grams and it has a volume of 10 cubic centimeters, and it's asking what's its density. So what I would like for you to do is pause the video and see if you can figure out what that would be, and then come back when you're ready. Alright, so if we take a look at our equation, we have density is equal to mass over volume. So plug in what you have, and normally I try to read through the sentence, especially if that's something that's tricky to start off with. Try to read through the sentence and figure out what the variables are telling you. So here it says it has a mass of 8. So this is my m variable, right? M for mass has a mass of 8 grams. It occupies a volume of 10 cubic centimeters. So it's giving you the volume and the unit that it's in. And then it's saying, okay, after that, what is the density? So rho is equal to, the mass is 8 grams, the density of this thing is 10 cubic centimeters, and if I do a little division here, 8 grams divided by 10 cubic centimeters, I get 0.8 grams per cubic centimeter. So a little messy, I'm just going to tidy that up a little bit. So I have my answer. I'm going to box in my answer, and then just a couple of little things that I'm looking for along the way. So it's a word problem, right? It gives you a scenario. A block of wood has this mass, so it gives you context in the problem, right? What is going on in the problem. So if I have a sentence question, I should have a sentence answer at the end that kind of explains everything. So what is the density? The density of the block of wood is 0.8 grams per cubic centimeter. So I'm just stating the answer at the end. When you are going through and working on these questions, I would obviously be expecting that you would be showing your work as well, and going through and kind of highlighting these points. So if it were, say, a 4-point question, just writing out the answer at the end, I am looking for more than that. So I'm looking for you to set up the equation, looking for you to plug in a little bit of work, show me the answer boxed in, and then if it's a word problem, it should have a word answer at the end, and that will kind of tell you 4 steps of the 4 stages in solving word problem type questions. Alright, so let's try number 2. So again, I'll get you to pause the video, give it a try, and come back when you're ready. Alright, so in number 2, it says a beach ball has a mass of 10 grams, so it's giving you the mass, and it's got a volume of 400 cubic centimeters. So here it's giving you what the volume is, right? Volume of 400 cubic centimeters. And then notice what it's asking, find the density. So set up the same problem. Density is equal to mass over volume. Density is equal to, we know the mass in this case is 10 grams. The volume in this case is 400 cubic centimeters. And I'm going to divide those numbers through from one side to the next. So 10 divided by 400 gives me 0.025. 0.025. Now notice my units here. Grams are on the top, cubic centimeters on the bottom. You have to include units. It has to have some sort of context here. So grams over cubic centimeters. We're going to box in our answer. It is a word problem talking about a beach ball. It wants to find the density of that beach ball, and you don't need much. We just need to say the density of beach ball is, and then our answer, 0.025 grams per cubic centimeter. So it gives us some sort of context in the question as defining what this density is. Okay, so we've got mass over volume, we've got 10 grams, 400 cubic centimeters, we found our answer, and then at the end of the day it gives us some kind of value to compare it all to. Alright, so again, I take a look at my 4 steps here that I'm checking off as I go. So I have an equation, I have some work plugged in, I have an answer that also includes the right unit, and then I have a sentence answer at the end if it's a word problem type question. Okay, so I'm including all of my steps. So these ones are not word problem questions, they're just straight plug and play questions for practice. Each one is asking to solve for something different, and so I'll get you to try out each one and pause the video, go through and try them, and then when you come back we'll kind of talk about a way to go through and to solve each of these questions. Okay, so pause the video, give them a try, and then when you're ready, come on back. Alright, so let's try out the A question. So the A question starts us off solving for rho, solving for density. It's equal to mass over volume. Density is equal to, my mass is 6 kilograms. My volume is 3 cubic meters. And so density is equal to 2 kilograms per cubic meter. Okay, 6 divided by 3 gives me my 2, and then kilograms over cubic meters as a unit. There's no context here, so I don't need to have a sentence for an answer. The B question, this one's asking to solve for mass. Now, we haven't got to this part yet where we've had to solve for a variable other than density. So I'm going to show you a little trick. It's definitely something that you should write down, have somewhere to reference, especially if rearranging equations doesn't come easy to you. So if it's something that you maybe need a little bit of practice with. Whenever we have these 3 variable equations, we can always set up a little triangle that helps us figure out what to solve for. So what I always do is I take the equation I know, I draw a little triangle, and that triangle has a line going across kind of the center of it, bisecting it, and then it has one going down the middle of that line that I just drew. Now inside that triangle I'm going to take the ratio that I have, m over v. So you see how this one here, mass over volume, from my A question, I'm going to write that mass over volume the same way here using my horizontal line as a division line. So I'm going to write mass on the top and volume on the bottom. Now there's only one space left that it can go, and that density is going to fill that spot. So this division line tells me that mass is always going to be on the top when I need it to solve for something. Now the vertical line that's there between the P and the V, between rho and your volume, this line is going to be treated as a multiplication line. So if I want to make the equations for this thing, I have one already. Density is equal to mass over volume. I can figure out another one. Volume is equal to, and then if I take a look at volume and the other 2 letter left, well, I can see mass is on the top, density is on the bottom. So mass on the top and density on the bottom. And then after that, if I want to solve for m, then it's just the 2 of them on the bottom, and then that vertical line means multiply. So it's really just density times volume. So I can use that triangle to actually rearrange for any equation. And so that's really where we're at next here. So in B, I need to solve for mass. I can go to my triangle and I can see that mass is just really the 2 terms multiplied together, density times volume. So density, in this case, 3.5 grams per milliliter. So I'm going to set up my equation. Okay, P and V. I'm going to open up brackets when I put my numbers in here, just so I have kind of place values for them to say where they go. So 3.5 grams per milliliter, and the volume of this thing is 20 milliliters. So 3.5 times the 20 that I have gives me 70, and then 70 what is the question? Well, this is a mass, and so remember, mass units tend to have things like grams and kilograms as units, and if I can look here, I actually have this kind of set up like a fraction. I have milliliters on the bottom in one step, and milliliters on the top in the next step. This is like saying 2 divided by 2, or 5 divided by 5, something on the top and that same thing on the bottom. So what's going to happen here is the milliliters units actually reduce to 1, they cancel out. So I'm left with just grams as a unit, which makes sense because I'm talking about mass. I'm talking about a mass unit. So hopefully that was okay to kind of run through. In C, this case it's asking to solve for volume. So my volume equation that I'm going to go to is going to be the middle one that we made from before. And I'm going to use the triangle, and I can see volume is equal to mass on the top and density on the bottom. So volume, C, volume is equal to mass over density. So volume is equal to mass on the top, which gives me 20 grams. And on the bottom, my density, I have 2 grams per cubic centimeter. And so my volume at the end gives me just 10 cubic centimeters. And so this one might seem, okay, well, how am I getting the cubic centimeter unit out of here? Because I have grams in here. And if you're talking about volume, remember, volume doesn't have a mass unit in it. Volume is milliliters, gallons, liters. So if I look at my units here, and again, this is just a little bit extra, but it explains what happens. Look at my units. I have a grams unit on the top divided by a grams per cubic centimeter unit on the bottom. Now, what do we do when we have fractions and there's a division? Well, the answer is to flip the second term and multiply. That's your kind of the rule that you've learned when you're dividing fractions. So grams, I'm going to flip the second term, centimeters on the top, grams on the bottom, and I'm going to multiply. Well, what happens here? This is the same thing as what I just canceled it with milliliters in the B question. Grams are going to cancel top and bottom. They reduce to 1. And what am I left with? Cubic centimeters as a unit. So that's what goes in my answer. So hopefully that helps just kind of introduce a little bit about density. When you're ready, we'll continue on with the next video.